Homework help with Jen. We're going to do problem 81 from chapter 4, and we're actually not going to do all of it. It's a very long problem, but we'll just begin. What they're looking for in this problem is they're looking for oxidation states, and actually they're only looking for the nitrogen involved in each case, but we're just going to find the oxidation states for everything, and that'll be a good crash course for us. All right, so looking at this first one is lithium nitride. Okay, so we know from our ion list that the nitride anion is N3 minus, so the oxidation state here is a -3. Lithium, Li plus as an ion, is +1. Okay, and we check to see if those balance because we have a -3 charge here and we have 3 +1 charges, and that makes for the whole thing to be neutral, so we're good. So now let's look at NH3+. Okay, so hydrogen tends to be a +1, except in some very rare hydride type conditions. Okay, so if each hydrogen is a +1 and there are 3 of them for +3, then that means that in this case our nitrogen is a -3. So let's look at the next one. Okay, so this is N2H4. It's another nitrogen-containing compound, just like NH3. Each hydrogen is a +1. Okay, and there are 4 of them, which gives me an overall +4 charge. The nitrogen, there are 2 of them, and they need to balance to make that work. So each nitrogen has a -2 charge, or oxidation number on it. All right, now we have an N2O. So oxygen is -2. This isn't a peroxide. There are 2 nitrogens to go with this. So each one will have a +1 charge so that we have 2 +1 charges to balance out the -2 charge. So as you can see, nitrogen is one of those that can change quite a bit. Okay, so now we have the nitrate ion. And now in this case, they don't add for 0, but they'll all balance to a negative there. Okay, so we have oxygen, and again, oxygen is a -2, except in the rare peroxide case. And there are 3 of them. That makes an overall -6 charge. But I only have to balance out 5 of the negative charges because I'm going to be left with 1 here. So that makes the nitrogen a +5. And last but not least, we have N2. Well, this is nitrogen in its elemental gaseous state. And a compound in its elemental natural gaseous state is going to have an oxidation number of 0.